Next is question number 56, that is column matching type. Here different values are given in column 1 and column 2 and we have to match them. So let us start with the option number 1. Now to solve this, let us firstly write the expansion of 1 plus x raised to the power n. That will be equal to nc0 plus nc1x plus nc2x square and so on, right? So if I put here x equal to iota, then we will get 1 plus iota raised to the power n is equal to, writing firstly the real part, that will be nc0 minus nc2 plus nc4 and so on. And if I take iota common, then we will get nc1 minus nc3 plus nc5 and so on, right? So this is the value of 1 plus iota raised to the power n. Now if I multiply and divide here by root 2, then we will get root 2 raised to the power n into 1 by root 2 plus iota by root 2 raised to the power n. That can be written as cos pi by 4 plus iota sin pi by 4 raised to the power n, that is e raised to the power iota into pi by 4 into n, that is it can be written as root 2 raised to the power n into cos n pi by 4 plus iota into sin n pi by 4. This is what we can write it. Now from here it can be seen that the value of nc0 minus nc2 plus nc4, that is the real part, will be equal to real part on the left hand side, that is it is equal to root 2 raised to the power n into cos of n pi by 4. Also the imaginary part will also be equal, that is nc1 minus nc3 plus nc5 and so on. This value will be equal to root 2 raised to the power n into sin n pi by 4. Is it clear? Okay. Now in the first option we have to find summation. Putting k equal to 0, we will get 29c0 with minus sign plus 29c2 minus 29c4 and so on, right? This is what we have to find. Now putting in equation 1 n equal to 29, so we will get 29c0 minus 29c2 and so on equal to root 2 raised to the power n, that is 29 into cos of 29 pi by 4. Cos 29 pi by 4 can be written as 7 pi plus pi by 4, that is equal to root 2 raised to the power 29 into minus 1 by root 2. So this is equal to minus root 2 raised to the power 28, that is 2 raised to the power 14. Now as we have to find minus of this value, so its value is equal to 2 raised to the power 14, right? Firstly let's find the values of all the 4 expansions, right? Now let's find the second option, in which we have to find the value of, putting k equal to 0, we will get minus 31c1 plus 31c3 and so on, right? This is what we have to find. Now in equation 2, let us put n equal to 31. So we will get 31c1 minus 31c3 and so on is equal to root 2 raised to the power 31 into sin 31 pi by 4. That will be equal to minus 1 by root 2. So this is equal to minus of root 2 raised to the power 30, that is 2 raised to the power 15. As we had to find minus of this value, so that will be equal to 2 raised to the power 15. Is that clear? Now next, in third question we have to find the sign is of multiplication from r equal to 0 to 6. Now the value of 7cr plus 7cr plus 1, that can directly be written as 8cr plus 1, and we have multiplication here from r equal to 0 to 6, and in the denominator we have 7cr, that is 7 factorial upon 7 minus r factorial into r factorial, and here we have r plus 1 also. Let's multiply in the numerator and denominator by 8. So this can be written equal to multiplication from r equal to 0 to 6 8CR plus 1 into 8 upon, now this value can be written as 8CR plus 1, right? So we have here 8CR plus 1. Cancelling these two, it is equal to multiplication from R equal to 0 to 6 of 8. As we are multiplying it 7 times, so this is equal to 8 raised to the power 7, that is equal to 2 raised to the power 21, right? Similarly, let's solve fourth part, which says that multiplication from R equal to 0 to 14, R plus 1 into, taking in the denominator 15CR common, in the numerator we will have 15CR plus 15CR plus 1. That can again be written as 16CR plus 1. Again multiplying by 16 in the numerator and denominator, we will write it equal to multiplication from R equal to 0 to 14, right? The denominator will become 16CR plus 1. So this whole will get cancelled with this term. So we are left with 16 multiplying 15 times, that is equal to 16 raised to the power 15, that is equal to 2 raised to the power 4 into 15, that is 2 raised to the power 60, right? So this is the answer that we get from the fourth option. Now option number P says that it has less than 22 positive divisors. Now option number 1 have 2 raised to the power 14 have 15 divisors. So P will come here. P will come here also. As 2 raised to the power 21 has 22 divisors, so option number P will not come in the third and fourth option. Now option number Q says that it has only one prime divisors. That is true for all the four because 2 is the only prime divisor here. Therefore Q will come in the answer of all, right? Now we will talk about option R later on. Now S says that it is divisible by 2 raised to the power 20. Now, which of the numbers are divisible by 2 raised to the power 20? This and this one. Also, T will come in here and here, right? Now we are left with R option. Now to find the number of digits, we have to take logarithm, right? What is the method of finding the number of digits? Let us say we have to find the number of digits of 2 raised to the power 14. So let us take T equal to this. So we have to find log T, that will be equal to 14 into log 2, that is equal to 14 into 0.3010, that will be equal to 4.2. Now this will mean that it will have 5 digits, but in the question it have been asked even number of digits, so it will not be the answer. Similarly, let's find for T1 equal to T raised to the power 15. So here we will find 15 into log 2, that is 15 into 0.3010, that will be equal to 4.5. So this again have 5 digits. Now next for 2 raised to the power 21, it will be equal to 21 into 0.3010, that will be equal to 6.3, which means that it will have 7 digits. Similarly, finding for 2 raised to the power 60, we will get 60 into 0.3010, that will be equal to 18.06, which means that it will have 19 digits. So all of these have odd number of digits, so R will not come in any of the option. So from the given options, it can be seen that correct answer is given in option number B. Next is question number 57, which says that in question number 1, limit n tending to infinity, n factorial upon n raised to the power n is equal to, right? Option number 1, n factorial, that is 1 into 2 into 3 up till n, and in the denominator we have n times, right? So it can be written less than equal to, let us write 1 by n as it is, and in the denominator I am writing n as it is, right? So this is less than equal to, if I take n instead of 2, if I take n instead of 3, and so on up till n, right? Also it is greater than equal to if I put 1 instead of 2, 3, 4 up to n. So it is greater than equal to 1 into 1 into 1 up till 1 upon n into n into n. We will get limit n tending to infinity. Here we will get 1 upon of infinity, that is 0 is less than equal to. Here putting limit tending to infinity, let us say the value is L. So L is less than equal to, here putting limit n tending to infinity, as these all will get cancelled. So here 1 by infinity will be 0. Now by sandwich theorem it can be proved that the limit of this will be equal to 0. Right? Now similarly, let's solve second question. Now we know the property of logarithm, that is a raised to the power ln b can be written equal to b ln a. Right? Limit n tending to infinity, the numerator can be written as m ln n, and in the denominator the same thing have been written, so these both will get cancelled, so the limit will be equal to 1. Now let's solve third question, which says that limit x tending to 0 plus 1 minus cos to theta is equal to 2 into sine square theta, that is I can write it as root 2 into sine x. Modulus have to be applied, but for x tending to 0 plus it will be sine x. And in the denominator also we have root 2 into x. These two will get cancelled and sine x upon x will tend to 1. So the limit is equal to 1. Similarly, let's solve the fourth option, which says that limit x tending to 0 minus. Now when x is tending to 0 minus, then fractional part of x will tend to 1. So it will be 1 raised to the power 1. So the limit will again be equal to 1. Also, let's find the limit given in option number P. That is ln of limit x tending to infinity 1 by e into 1 plus 1 by x raised to the power x whole raised to the power minus 2x. We have to find its limit. Let us say it is equal to L1. So this is equal to limit x tending to infinity taking ln inside, then the power minus 2x can be taken out. That is minus 2x into ln of 1 by e into 1 plus 1 by x raised to the power x. So this is equal to limit x tending to infinity minus 2x into ln of a into b can be written as ln a plus ln b. That is, it can be written as ln 1 plus 1 by x raised to the power x can be taken out plus ln of 1 by e, that is minus 1. So this is equal to limit x tending to infinity minus 2x into x into, now we know the expansion of ln of 1 plus x, that is equal to x minus x square upon 2 plus x cube upon 3 and so on. So it can be written over here like ln of 1 plus x is 1 by x minus 1 by 2x square and so on, right? Minus 1. Now this minus 1 will get cancelled with x into 1 by x. So this will be equal to limit x tending to infinity minus 2x square into minus 1 by 2x square, and in the next term I will have 1 upon 3x cube and so on, right? So this is equal to, these two will get cancelled, 1 plus minus 2 upon 3x and so on. Now putting here limit x tending to infinity, so these terms will get cancelled and the limit will be equal to 1. So here this limit is equal to 1. Now similarly, let's find the limit given in option number T, that is limit n tending to infinity sine of greatest integer of n whole raised to the power n. As we are given a integral multiple of sine, that will never be minus 1 or 1, so the value will be lying between minus 1 to 1, right? Now if we raise infinity to this range, then the value will tend to 0. So this limit is tending to 0. Now let's match the answers. Option number 1 we have Q and T, and for option number 2 we have P and R. For option number 3, again we have PR, and for this also we have PR. So from the given options, it can be seen that answer is option number C.